All right, welcome back to this third part of mill-turn machining tutorial of NX manufacturing. In this video, we're gonna go and finalize few other operations that left and quickly show you from the tutorial how to get output of the file, which are the post-processing file and shop documentation and so on. All right, so previously we have defined the operations until milling the slots on the parts, and now the two remaining ones are the defining the spot drills and cut off the parts, and also on the other spindle facing the other part or the back side of the part component. With this in mind, that currently in this tutorial, the other side spindle is only responsible for facing the back side of the part. However, it could be another complete set of the operation on the other side of the part. But in this specific uh, tutorial, we're gonna only do the facing. But just for your information, you can basically repeat whatever operation. The only different thing is that you need to make sure you are selecting the spindle sub and not the spindle main, as we were doing normally. So, okay, let's go and finalize these few operations. And I will first again show you on the slide and then go back to implement it in the software. So for the hole features, you can either defining these holes one by one, or you can use the hole features recognition in the software and generating automatically this drilling for all these holes rather quickly. So it's just about first to run the software in a way that it recognizes all these holes automatically. So you can see on the right side how to define this parametric recognition on the workpiece. And then after that, the holes are detected. Then we're going to select it on the main part, on the main spindle, because the same holes are detected on the main part and on the spindle part, of course. But now we're gonna only define using it for the main part. So only selecting those ones, those 5 holes in the main spindle part. And then we choose the geometry as machine coordinate system hole making. And then we're gonna go through the spot drill and drilling, and I will show you how to work. And another one is about how does the tool moves from one point to another point, so that now, for example, on the left side, you can see that the tool make the hole, bring it back to the safe position, and move in like directly one to another point. However, we can make it neat and clean so that it rotates around or it revolves around the a circle in a safe distance from the part itself and going to the next next point that it shows on the right side. So kind of moving it from a bounding cylinder rather than straight from one point to another point. Then after that, we can cut off the part. We can either retrieve the tool or from the library or just define another tool manually, and then making sure that the cutoff part is taking place. This scenario is perhaps exactly the same than the turning one. So the idea is that we are deaccelerating the movement or feed rate of the cutting movement by 25% in the last 10 millimeter of the part, so that this huge force is actually not bending the part, but actually cutting the part. Then after that, we're gonna define another right-hand tool since it's gonna be on the other side of the spindle. So the right-hand tool will be used for facing the other one and finishing the spacing on the back side of the part. And then after that, we have the list of our components ready. And then the next step is basically taking the output is to define the correct post processor. For the post processor, for this specific tutorial, we are not going to use the the real post processor that we have in our lab, but just use a random one so that we can practice. But for the next exercise and next assignment, I will show you also how to define the post processor, which is only available in the campus on the computer campus and not on your personal computer. The next is to just getting out the shop documentation that is basically shows the sequence of the operation, manufacturing operation, the tool number, and a little bit of the path image that it can be shown. And I think that even by clicking it, you should be able to see in a larger view what is the path and so on. All right, so let's go back to the NX cam, and then let's start with the pattern recognition, and then we can complete the whole itself. So what we need to do is that we can go to the program view that we have, or actually we need to go to the geometry view. So I go to the geometry view and just make sure that this machine hole making is there. And when you are double clicking on it, you have the tool access on all access. Of course, it depends on the machine, but in this specific scenario, we are choosing in all access, and in the mill turn machine that we have in the lab, it used the same. So we just click OK, and now it's the step that we can go and do the pattern recognition. So for pattern recognition, there is on the navigation on the left side, there is something called Machining Feature Navigator. By clicking that one, I can see that they have these two ones here, and by right-clicking to the area, there is something called Find Features. So this is something that perhaps you can also finding out by typing it to the command area search. So I'll just click Find Features. So it will, I can see that now it will get the features from these two parts. However, I am now currently interested on the main spindle, but it should be all right. Make sure that this parametric recognition is on. We are looking for the, well, we can specify the geometry, but then it's very little by little you should, or surface by surface you should choose, or I can choose basically on the workpiece, which is now on the green one. And then I'm going to open this one and only select the steps. So I will uncheck the other ones. I'm not interested to find the other one. Maybe the holes would have been fine, but then this one is tested and steps give us a good result. And then we can select steps, and then with the, so this should be all right. I can open this. No, this should be all right. And then the machining access direction should be on none. After that, I will go to the next positions and then see that how can I find the features. And then we should be able to detect the features here. However, the off is now, maybe it's now running actually. Let me see. Well, I will wait for a while if it is now currently running. Or no, find features. Now I found it here. I was looking for it, okay, but now find features. And now I have the features selected, and you can see that it selected all the holes on both components. However, as I said, I'm now interested on machining in this one, but it could be the case that there would be some holes on this side that I would be using it. So there wouldn't be a problem as such. So now the holes are detected. I click OK and should just double check. I can see that there are 1, 2, 3, 4, 5 holes here, and then there are 5 holes there. And then I can see that these top one are basically on the sub spindle. And just to make sure, you can again go back to the top view, for example, and then we know that this is the left one. So these are the 5 that I am looking for. Either click it by control, either click it, the first one, and then the hold shift, and then the last one, then you have all the holes selected here. So what we need to do is now to create a rule-based feature process. So now I select this one. Let's see if I can do right click in these. Yes. And then after that, I will create the feature process. After that, I should be able to define the rule-based type. Yes. So I have a different type here. Either it is operation-based or rule-based. I put the rule-based now. And then here I am interested in basically a mill drill. So I will find it here. Mill drill is this one. Basically, I don't need to see this one. So this is the mill drill that I am interested, and pay attention to this geometry. Geometry should be chosen as machine coordinate system hole making. After that, I click all right, okay. And then now I should be able to see uh, if I go to the machine view, let's say this one, so operation navigator, and if I go to the program order view, I can see that these two are added here, but they are basically not generated still. To do so, I will just open this one. I can see that there are two sets of centers or spot drills and two sets of drills. For the spot drills, basically, I need to first activate those ones. So I will first click these ones and see that which of the holes. So this is the first I will attack the faced one, and then I will go through the side slots. To do so, what I need to do is just double click, or let me see again. Is it so? Or yeah, so it is this one. And then I can already generate these things and see that how does that look like. And then I can see if I can find something about tool display or tool settings, let's say. So this is non-cutting movements I have here, avoidance. So these are the things that I need to do. The collision is fine. So now what I'm trying to do is to generate this view that I can see because, well, let's generate this one, no parameter prediction available. So this is another that I need to figure it out. Let's see what will this one shows us. Let's play. Let's see that. Okay, there would be two spot drills. So as such, there wouldn't be any problem. But I would like to see the tool displayed moving. It's not necessarily now needed, but then we need it for the visualizing the movement of the drill, especially in the non-cut movement. I will pause this video and then try to find out, and I will record back again. All right, yes, now I managed to find it. So if you want to see basically the tool displayed in 3D, you should go to options here at the bottom of the list. Then you have the edit display. And then here from the edit display, we can select 3D. And then frequency, I think one should be all right. And let's see if we can see the tool. Yes. So now we can see that the tool comes here, then make the hole, come back to the position, go to the next point, making the tool and come back. And I think that anyway, frequency should be just a matter of showing how frequency shows this one. So now it was 1. Let's see what will happen. 3. So not a big difference anyway. So put it back again 1. And this is all right. So every time that is moving, it shows to us. And now I verify. So this is fine. And this would be all right. Um, then after that, it would be maybe the time to do the spot drill maybe on the side one, since it's basically the same, or we can find out the drilling as well. Well, maybe Phil, let's finalize this drill first. So I again double click this one, and then maybe I go back, or let's generate it first so that I can show it. No, sorry, this is the drill. Yes, correct. And then I can already generate this, and we can verify the movement again in 3D. Now the drill comes, and this is fine. And now I can show you the option. How does the movement look like? So this is how it works fine. So it should be all right. It makes a hole and then two holes. And this is how it was moving between the place to place. Now we're going to do and repeat the same for the other spot drill. So this is the second spot drill on the peripheral surfaces on the outside diameter. Let's say the tool is fine, and then let's generate these ones. Now you can see. So the tool will make first the hole, then it will go out, and it will go from one point to another point directly and then moving it. So you can see that the movement between these holes in the safe area is by just a linear movement. So maybe this is something that we can do it cleaner. And that is why defining these 3D steps, 3D display of a tool is a little bit helpful. So you can see how does the tool moves to make these holes. And now the idea would be to change it in the non-cutting move. Let's see if I can, yeah, it's here, non-cutting move. And I'm now want to change, I don't want to change anything about retraction or avoidance or something like that. The only thing I want to change is the transfer from one point to another point. So this one, if you remember previously, we defined it direct for saving some time in some previous operations. And then here, then between features, I can select or not in the direct, oh yeah, here. So clearance option, I can define moving on the bounding cylinder, and this is now 3. I can visualize, so this is the bounding cylinder here. So what would happen if I put 0? This is very bad. It's basically touching the parts, or it's not that bad. It's actually should be even enough, but just a matter of safety, I can put it 3. Well, let's try to see that if I can actually put minus. Yes, you can put minus, but it's a little bit risky. And then, well, let's put, for example, 5 millimeter, then it's super safe. But of course, I will waste some time. So these are the something that you can play and see that how much it affects the time that you can show that it's shown here, and you can see how much it has the effect. But for those ones, of course, you need to have the correct parameter settings from the feed rate, travels, and those kind of things. So this is the bounding cylinder, and I just, let's double check again. Bounding cylinder, this should be all right. I will regenerate again, and now you can see that how much it has changed. So this is how the tool will move. So this seems to be correct and neat, and there wouldn't be any collision. So generate this one, and let's see it even in 3D, or a lot slower. And this is the spot drill. The view would be better. So again, here it shows that the tool is moving, but in real life, it's actually the tool is in a fixed position and only the part is rotating. So this is something that you will see it also in the lab. So this is fine. I will repeat the same scenario here real quick. I will go again here to define it as a 3D so that we can see it better. I will go to the non-cutting movement, wrap it, and then I will define it as a bounding cylinder. 3 millimeters should be fine. I can check it out, regenerate the scenario, and then checking that there wouldn't be any collision or anything. No. And then I will verify it. Let's verify it in 3D in a slower speed and see that this is how it moves to another point, making the holes, moving to another point, and that's it. So now the main operations are completed here. What we need to do is actually to define the parting, or let's say cut off the parts, and then we will be done by this spindle for now. All right, so for defining the cut of the part, we need to first define our tool. Either we create a tool or we are just retrieving from a library. For now, we can just showing it from the library. So create tool, and instead of choosing the tool here, for example, I will just go and retrieve tool from library. I will choose a tool from a turning one, and then I have the parting. After that, I will just click OK, and there is a tool here that I can get, this one, and display the tool for now. Shows perhaps somewhere inside the component that I cannot see, which is fine. And then our, well, let's do that again because I forgot to define the tool station. Let's see if I have the tool here mistakenly defined somewhere. No, it's actually defined in the correct position in station 8. Yes, so this is the tool we're gonna use for cut off the parts. So this seems to be correct. And if I need to define holder and then shanks and that kind of things, which is available here, well, let's not go to that detail now, and let's see how to define the operations. After that, we create the operation. What we need to do is we are not going to do any hole making, so mill turn essential is something we need to choose. And from the operation list, we need to choose the cut of the part, or let's say parting or cut off the part or something like that. Let's see this. Yeah, this was the one, part off, on the same program, of course, and the tool, the new tool that we have used. So it should be UGT 114. So this is the one. It works on the containment main and rough lathe. Wait for a while, you can take a note from this one or remembering it. Click OK. And then from this, the parameters here, we should be able to define the cutoff position first, maybe. Defining the cutoff positions, and also the fact that the acceleration and then the millimeters and so on. So I will just take a look here. For example, from these feed rates, I can see that, well, for example, the spindle speed, it needs to be selected. Then after that, I need to find out the part of feed rates, which is here. And then let's see, these are the one. Oh, here, part of feed rate maybe is here. Oh, yeah, exactly here. So we need to decelerate, for example, by 30% in the last, let's say, 15 millimeters of the part, 10 millimeters of the part, whatever you are calculating, that it doesn't bend the part. So in this part, this is fine. This would be about this. However, there are some other settings that we need to do. And then the cutting parameters. I think these are fine. I'm looking for the place that I could define the position. Here, part of position, for example, I can make sure that this is automatic, but otherwise I can also define it. But when it is automatic, then it's already taken into account where the part needs to be cut off. So I can put it automatic for now. That shouldn't be a problem, but still I need to um, see that from the x-axis it's 0. So extend this value. I can put wait, clean the first wall, maybe extend the distance, or no, first wall. And then let's see what will happen if I regenerate this one. Let's see if it works out or if it shows some error. I need to see the top view. I don't see any generation. X-axis should be 0, which is correct. Let's see if it verifies or show me any tool. At least this one appears. Let's see if this one is working. No. So let's figure out what is the problem. So I will pause this video and try to figure out finally the troubleshooting, and I will pause again and tell you the results if I manage to find it. All right. Meanwhile, I managed to check the different version of the NX. So this is the Siemens NX version 12, and in this one it works nicely. So it's just a matter of different version of the software, and something was not working properly in the newest version of the software. So I just repeat the same process here for parting the components so that I can now show it to you in a better way. So again, similarly, I will first define the tool, mill turn, and then I retrieve the tool from the turning and parting component, which was, so until here, the process was the same. And then I have now the tool here, and then I will create the operation, essential mill turn, and then I have the parting option here. The program chosen correctly, the tool is the correct one, geometry containment main, and lathe rough. I will just click OK. So this is the same menu that I was having it before, and we're gonna have the same settings here. So part of here, automatic option here. We can select this one 1 millimeter to extend the distance, and then feed rate we can define deceleration in the last 10 millimeters of the parts by 25% in the last 10 millimeters of the part. This should be all right, and when I generate, it works fine. So the settings were the same, but the newer version of the software was not able to give us a good result. I now verify it, and now we can see that we have the cut of the part. So now that we are here, I'm actually not, well, let's see if we are able to define the next step. I'm not sure if I have followed this with this software. Well, anyway, let's define it. So the next one would be defining the right-hand tool. Well, we could perhaps copy this one, paste inside here, then going to the holder, changing it to a right-hand tool, and then the angle actually should be maybe 90 degree. Uh, style, and then the angle here 90 degrees so that it stands like this. Now it looks fine. And let's see if we are able to create the operation or it give it me the same problem as before. Create the operation, and then we have the 1 3, then we can choose the right hand tool that we just created. um, the right, oh yeah, I forgot to rename this. Let me first rename it to the right hand tool, that is easier to detect. Let's again create the operation, and we're gonna do um, facing, facing, 1 2 3, right hand tool, there he is. And then the avoidment, on in this one we need to choose the avoidment on the sub, and then lathe rough or lathe finish maybe better, and then facing on the sub. Let's figure this one out. Not quite what we are looking for. Let's see what will happen if I put sub. This shouldn't work. And then we need to define it with a different cutting region. So I just modify the cut region, axial trim plane 1. The distance would be, I think 1 should be all right. Yes, 0 is better. And then now creating the feature. Yes, so now this is the operation on the other side of the. So thank you very much for your attention, and let's come back with another video next week. Thank you very much.